There are two sets of traffic lights on John's route to work. The probability that he has to stop at the first set he arrives at is 0.4. If he does stop at the first set, then the probability he gets stopped at the second set is 0.3. If he does not stop at the first set, the probability that he gets stopped at the second set is 0.6. We want to find the probability that he only gets stopped at one set of lights. Once again, this is a situation that lends itself very well to the use of a tree diagram. Here we have the first branch of that tree diagram. This branch is going to represent the situation at the first set of lights. We need a second pair of branches to represent the second set of lights. So here we have the first set represented by the first branch, and the second set represented by the second pair of branches. We now need to extract the information from the question to put onto the branches. The probability that he has to stop at the first set is 0.4. So we could have stop and not stop, and the probability he has to stop is 0.4. So for not stopping, the probability is 0.6. Remember, the sum of these two has to be 1. He's either going to stop or not stop. So it's certain that he's going to do one of these two things, and therefore the probabilities must add to 1. If he does stop at the first set, then the probability he gets stopped at the second set is 0.3. That's going to be this top branch, because this top branch is where he gets stopped at the first set. So this is 0.3, and for not being stopped here, it must be 0.7. Once again, the probability is adding to 1. If we now look at the bottom branch, this is where he does not stop at the first set. The probability of getting stopped at the second set is now 0.6. So this is 0.6, and this one will therefore be 0.4. We want the probability that he only gets stopped at one set of lights. So he could stop at the first set and not at the second set, or he could not stop at the first set and stop at the second set. The probabilities here are going to be 0.4 times 0.7. And calculating this gives us 0.28. Here we do 0.6 times 0.6. This gives us 0.36. Since it could be either of these, this is an OR. He either stops at the first set and not at the second, or not at the first set and stops at the second. When we see OR in probability, we add, so 0.28 plus 0.36, which is equal to 0.64.